So why do chemical bonds even form? Much of nature is driven by changes in energy. So if something goes to a lower energy state, then it's more stable. It's like a ball rolling down a hill. Balls roll down hills because when they do so, their potential energy is lowered. Balls don't roll up hills. It just doesn't happen. So chemical bonds form because they lower the potential energy between the charged particles that compose atoms. Atoms have protons, which are positively charged, and electrons that are negatively charged. And an atom can lower its potential energy by bonding with another atom. There's a lot of interactions going on here. We've got electrons repelling each other. We've got nuclei repelling each other. And then we have electrons and nuclei being attracted to each other. So it's a complex set of interactions. A bond will form if the combination of those interactions results in a reduction in energy. So we'll talk about three kinds of bonds: ionic bonds, covalent bonds, and metallic bonds. So ionic bonds form between metals and nonmetals. So metals have low ionization energies. They will lose electrons readily to form cations. Nonmetals have negative electron affinities, which means they will gain electrons to form anions. And so what happens is the metal transfers its electrons, some of them, to the nonmetal, and then we have oppositely charged ions, and they're attracted by electrostatic forces. And that's the ionic bond. So ionic bonds are between metals and nonmetals, and the characteristic is that electrons are transferred. Between two nonmetals, we're going to have covalent bonds. The characteristic there is electrons are shared. And within a metal or a metal amalgam, you've got metallic bonding, and there the electrons are pooled. And we're not going to talk about that one nearly as much. So the covalent bond is one we're going to talk about more. So nonmetals interact by sharing electrons. And those shared electrons are attracted to both nuclei, and that's what holds the two atoms together. So if this is the positive nucleus of one atom and this is the positive nucleus of another atom, an electron shared between them is going to attract both of them. If it's off to one side or over here, that's not the lowest energy state. The lowest energy state is if this is in the middle, right between. So this is the most stable. So this electron being shared between the nuclei pulls those atoms together and lowers their energy. Metallic bonding occurs between metal atoms. Now, metals will lose electrons easily, but they don't want to gain electrons. And so you've got these metals that are willing to let their valence electrons run off without them, but nobody's willing to take them on. And so I think of this as like a neighborhood. I think of electrons as being a lot like children, especially little boys. They're very squirrely and unpredictable. So you've got this neighborhood, and the moms in the houses are like the nuclei. You know, they're the center of the family, and the electrons are just kind of out there. So the moms send those valence electrons outside to play, and they run around the neighborhood. It kind of, everybody sort of keeps an eye out for them. If you see a kid, you know, doing something bad out the window, even if it's not your kid, you might go out there and yell at him. You know, that's not safe, quit doing that. So what happens is, we call this the electron sea model. And so the electrons are just kind of floating around within the metal. We can also describe this as the atoms in the metal lattice. The lattice is the arrangement, because metals are solid at room temperature, right? So they're arranged in a particular order, and then the electrons are just like a pool around them. The electrons are delocalized. They're not attached to a particular atom. And this is why metals can conduct electricity. Those electrons are delocalized. They can move. They can move over, and one will come in and take its place. And so metals conduct electricity in that way. So we've got the positive nuclei, and they are attracted to that negative sea of electrons, but they're not attracted to a particular electron. Okay? Now, the metallic bonding is a little tough to understand, but we don't have to understand it very much, so that's good.